All right, 6.2, area. So there's a lot of things we need to discuss with area. And one of the main things with integrals is how it helps us find the area of certain items that we don't necessarily might not have a formula for. And so then, of course, some that we do have a formula for. So there's things we need to talk about that build up to that. And one of those things is sigma notation, okay? And sigma notation, you might have seen enough if you took other math classes, but to some of you, these might be brand new. So this I equal to 1 tells us it is our lower bound and n is our upper bound. Sigma notation you might also hear as summation notation, right? So summation using the word sum, right? So you get some sort of formula here, and then based off of what your lower and upper bounds are, you add up all the terms together, okay? So in this case, you start at 1, and then you add everything up until n, and you plug them in. We'll do a few examples as to where, how this will be applied, and we'll do some basic ones. Let's say we have a summation of I equal to 1, and the n value being 4, and that we just have an unknown of I. What would that be equal to? Well, whenever we are using our sum, so first term is 1, so we plug 1 in for I, it's going to be just 1. Plug 2 in, be 2. Plug 3 in, 3. Plug 4 in, 4. You add those all up, you get 10. So your answer would be 10. By just plugging in, starting at whatever the lower bound, all the way up to the upper bound. So here are 4 different summation formulas we will be applying. And we'll show you an example here in a moment. I recommend you pause the video, write them down, and then you'll see, oh wait, that makes more sense then. Hopefully that will happen in a moment. Example of this, we have I equal to 1 to 24 for the summation of 4i. So where we see I at? We see I with the formula right here, right? And also we can just take a 4 out momentarily and go 24, I equal to 1, and I. So what's the formula? N, parentheses n plus 1 over 2, right? All times 4. What is your n equal to? Your n is equal to 24, so it'll be 24 times 25, because 24 plus 1 is 25 over 2. When you plug that all in, what do you get? You get 1200. There you have it. All right, so we have the function f of x equals 3x plus 2. Now, this is an easier one we can probably find the area of, because right now we're trying to find the area under, between the graph of f of x and the x-axis. But the thing is, I'm going to use blue here to kind of connect them. What we're going to do is use rectangles for now, okay? Rectangles, and we're going to use 6 of them, okay, with right endpoints. Meaning, I'm going to make one right here. So start at the right endpoint and make a rectangle. Since there's 6 of them, there's going to be one at every half x. Okay, so when we're trying to find the area of this, what point is this? Right here. Well, we know that point right there, when we put 3 in, we're going to get an output of 11. So your height is 11. And our base is 0.5. So far we have 11 times 0.5 plus next right hand point. So that would be, stick to red, so this point right here all the way to where 2 is. When we put in 2.5 in, we're going to get 9.5, so 9.5 times 0.5. Next one at 2. At 2, we put 2 in, it's 8, and of course the base is 0.5 again. And then you put 1.5 in, and you'll get 6.5. And of course, at 1, your output is 5, and distance is 0.5. And the last one at 0.5, and then 0.5 at 0.5 is going to get you an output of 3.5. You add that all together, and what do you get? And we'll get a sum of 21.75, and it might ask you for left endpoints, which would just be the opposite. I'm not going to go through this whole thing because we're going to be doing a video for a while, but you would simply just go boom to boom, okay? So it'd be working from the left and going to the right instead, okay? So keep that in mind. If you ask for left endpoint, start from the left and pick the point from the left and go right. Right, we do what we just did. All right, we are going to find the area below here from 0 to 4, and the directions say here use rectangles with a width of 1. Okay, so let's go from let's do left first. I'll use blue for left. With the 1, with the 1. With the 1, with the 1. So 1, 1, 1. What's height there is 1, 1. So 1 times 1 plus, we got 3 times 1 plus 4 times 1 plus what looks like about 3.5. Round that 3.5 times 1. You add it together, you get 7.5 plus 10.5, 7.5 plus 10.5, 11.5. Is that what I'm getting? Wait a minute, it should have been 4.5. My bad. How did I get smaller here? I don't know. Should have been, it was like halfway between 4 and 5, so we're going to call that 4.5. So it's going to get us about 12.5. Now let's go from the right. When we go from the right, what happens? We use red this time. And so we have 3 times 1 plus 4 times 1. It's all the same, except the only change here, instead of 1 times 1, you're going to have 5 times 1, because we went from the right. You add it all together, you get 16.5. So the area is somewhere between 16.5 and 12.5. We're going to approximate, right? If we said 16.5, it's probably an overestimate, right? Because we're way over the graph. 12.5 would be underestimate. So we are slowly getting to where we can find approximately what it is, exactly. And that's what we're hoping to do eventually by keep building. All right, here's the definition of the area of a region in a plane. Let's say we have fx is on the interval of a to b. This is a to b, okay? And it's continuous and non-negative. And we have these two vertical lines at x equal to a and x equal to b. That's kind of what we were doing in the last couple of problems, right? We had an end and a start and an end where we kind of had our area in between two values. At the last problem it was 0 and 3, and so on and so forth, right? The definition is the area is equal to the limit as x approaches infinity of f of ci, so by times the change in x, where the change in x is equal to b minus a over n, okay? So, a lot there. We'll apply it, don't you worry. So let's remember, the endpoints of our graph divided by whatever your n is, okay? So that's your change in x, and then it's based off of our function, okay? So let's do some practice. All right, here's an example we're going to have. So we have y equals x squared plus 1 on a interval from 0 to 1. So we need to find the area. So let's set area, just like our formula, be consistent. Area is equal to the limit as n approaches infinity of f of ci times change in x the limit as n approaches infinity of. Now, normally we will make our f of ci, where the x input will normally be I over n, okay? So when we do this, I'm going to basically substitute I over n in for x. And what's our change in x? Our change in x is going to be also I over n. These will basically represent our endpoints. This right here, right? This is our change in x. That's where that little change symbol that we had. This is our change in x. This right here is going to be represent our endpoints. This 1 over n, I think I said, did I say I by accident? No, it should be 1. This is a 1 over n. So when we go to solve this, we FOIL out a little bit. And when we FOIL out, and we are foiling it, so it's going to get us I squared over n squared plus 1. 1 over n. What we can do temporarily is move the 1 over n out. And then keep the rest inside here. And then if we take this into two separate my summation thing, a little messy, my apologies. Hopefully, I'm sure you figured out what it was. And we know right away that 1 will be 1n, but we can also take out 1 over n squared and when we took 1 over n squared out, we were left with I squared plus, and we know that it's going to be n. So, and based off those lovely I squared formulas that we talked about earlier, that will get us n parentheses n plus 1 parentheses n plus 2 over excuse me, or rather 2n plus 1, my bad, over 6 and plus n. If we FOIL out this whole thing right here, that would be and that will get us n cubed, 2n cubed, plus 3n squared, plus n over 6, plus n. And I'll go on the next page because we're almost done. I distribute that 1 over n squared to all three terms, and it got me that. If I add n, I'll get us, forgot the 1 over n, 4 over 3n, because 1 over 3 plus 1 is 4 over 3. And then distribute the 1 over n, be 4 over 3, plus 1 over 2n plus 1 over 6n squared. And this is where limits come into play. Limits can, as we go to infinity, will just be 4 over 3 plus 0, which will be equal to 4 over 3. There we go, we did it. All right, appreciate you watching. Take care.